Hello everyone, good day. In this video, we are going to see the demo on how to create the YAML manifest for persistent volumes and persistent volume claims. If you like this video, please subscribe to vSpark's channel and click the bell icon for the latest updates. This is the agenda of this video. First, we will be seeing the architecture diagram. Second, we will be discussing the sample YAML manifest for PV and PVC. Finally, we are going to see the demo on how to create these YAML manifests. This is going to be the architecture diagram for our demo. First, we'll be creating a pool of PVs using the local storage system of the worker nodes. This type of manually creating PV is called as static provisioning. When we are using the local storage, it is mandatory to specify the node affinity constraints for our PVs so that the PVs will be created in the appropriate nodes storage system. Once the PVs are created, we will be creating persistent volume claims, that is PVC. Based on the properties of the PVC request, these PVCs will get bounded to the appropriate PVs. In our case, this PVC claim should get bounded to PVC3 as it is matching approximately with the PVC claims request. Sample YAML manifest for PV and PVC. If we see the PV definition, the main fields are API version, kind, metadata, and spec. The value for API version is V1 and the kind is going to be persistent volume. Under metadata, we can specify the name of the PV. Under spec, we can define the properties of the PV like access modes, capacity, reclaim policy, volume modes, etc. etc. Populate the values as per our storage needs. Along with this, we need to specify the underlying storage also. In our case, it is the local storage. The path we are mentioning here should be the path you should have already created in the worker node as a directory. But in which worker node we should create this directory? This is decided by the node affinity constraints. As per this node affinity definition, this PV should be consuming the local storage from worker node number 1. Now it's time to see the definition of persistent volume claims. This PVC claim is going to be a request for using the persistent volumes. As usual, the definition starts with the main fields like API version, kind, metadata, and spec. Within this claim definition, we need to specify the specifications of our claim. We need to specify these things based on our storage requirements. Pods consume CPU and memory resources. Similarly, these PVCs consume PV resources. Based on the properties of the PVC request, these PVCs will get bounded to the appropriate PVs. Here, one such request is storage capacity, which is 2 GB in this case. So, this PVC will get bounded to the PV which is having a 2 GB of storage capacity. This is one of the request constraints which the PV should satisfy. There are other request constraints like access modes, volume modes, and so on. Now, let us see the demo. Step 1. Access and inspect the Kubernetes cluster. Access the Kubernetes cluster using Kubectl utility and check if the Kubernetes cluster is running properly. This is the master machine where we have installed the Kubectl utility and connected to the Kubernetes cluster. Kubectl cluster info command gives the details of your cluster. Now check the nodes. Our cluster is running with one master and two worker nodes. Now check the parts in the kube system namespace. Yeah, you can see all the cluster components are running properly. Step 2. Create the underlying storage system. Here we are going to use the worker nodes directory as the storage system. We are going to create these directories in the worker nodes. In worker node number 1, create a directory called pv/pv-1. -p implies parent directory creation if it was not present. Similarly, create pv-2 and pv-3 directories respectively in worker node number 2. Now we can see all the required directories are created. Step number 3. Create and apply persistent volumes using YAML Manifest. In this step, we will be creating a pool of PVs using the YAML Manifest. These PVs should use the directories which we created already as its storage system. Let us create the PV definition file from the scratch. Kubectl API-resources gives the list of Kubernetes objects that are supported in the cluster. So PV is one of the object among this. Kubectl explain command gives the exact skeleton or the structure of the Kubernetes object. Let us first try to create an empty file and then we can populate the required fields. The main parent fields of this PV object are API version, kind, metadata, spec and status. Status field is a read-only and it must be populated only by Kubernetes after the creation of objects. Let us describe the spec now and populate the YAML file based on the storage needs of our application. Ensure that we are using the correct data type for these fields. Possible data types are strings, arrays, and objects or maps. Array should be defined using hyphen, object should be defined using a key value pairs. Now let us define the local storage. For describing the subfields, just type parent field dot subfield in our explain command. Under path, just mention the directory which we have created in the worker node. We want this PV to use worker 1's storage and hence using its directory. Node affinity is mandatory when using the local storage. Construct this node affinity in such a way that this PV should select worker node number 1 as its local storage system. Make use of node labels to work with node affinity. Since we are going to use node labels, we are defining match expression field here. Here we are extracting the node label from worker node number 1 and we are using the same in our PV definitions. Here the key is kubernetes.io/hostname and the value is worker01.kubernetes.com. Once the PV definition is done, apply the same in the cluster to create PV-1. Now PV1 is created with a capacity of 1 GB. Similarly, create PV2 and PV3, but this time create it in such a way it should use worker node number 2 as its local storage system. For PV3 alone, we will be using the accessing mode as read write once. Seems there is a typo error, we will fix it and then we will apply the same. Now PV2 and PV3 are also created. Step number 4, create and apply persistent volume claims using YAML Manifest. Similar to the PV definition, create PVC definition as well. But in the PVC definition, we need to specify the resource request. Yes, this PVC claim is requesting for a PV which should have the access mode as read write once and a 2 GB storage capacity. PV3 is the only volume that matches with this criteria, and hence this PVC will bound to PV-3. Let us create this PVC claim and apply the same. Now PVC claim is created. As per our prediction, we can see that this PVC is bounded to PV-3. Well, that's it for this demo. Thank you from vSparks and thank you for watching this video.